What's up, guys? This is the last section of chapter 14. It's about combining functions. We also did this last year, so just a little bit of review, but I want to go into some more in-depth algebra stuff. So this solved problem says two jewelry stores are each having a sale. Store A is offering 50% off each jewelry item, while store B is offering $20 off each jewelry item. Write a function f of x giving the difference between store B's sell price and store A's sell price for an item that normally costs X dollars at each store. How much more would you pay at store B, as being shown? Okay, so our function is f of x. We're looking for the difference, so basically we're just subtracting the two functions. For store A, we would do, is that what it wants? Write a function giving the difference between store B and store A's. Okay, so we're going to do store A, which is 15% off. So 15% off, you're paying for 85% of the original price. So we're going to say 0.85x. Subtract this one, you're taking $20 off, so it's just going to be your sell price or your original price. Subtract 20. Okay, and then obviously we can distribute the negative through to simplify this a little bit. So we get 0.85x minus x plus 20. Combine like terms, we get negative 0.15x plus 20. Okay, and then for this one, for a ring that's $300, you just plug that in. It says how much more would you pay at store B? So actually we should have done B minus A, but that's okay. It'll just give us a negative number here. So we just plug 15 in for, or 300, wow, in for x. So 300 times 0.15 equals that, 45 plus 20. Oh wait, it's negative. Negative 45 plus 20. So I get negative 25 when I plug in 300. So f of 300 equals negative 25, which basically means you're paying $25 more at store B than store A. Okay, because we did A minus B instead of B minus A. Okay, so if you have two functions, f of x and g of x, you can add, subtract, multiply, and divide them. F plus g of x is written like this, f plus g in parentheses of x. It just means f of x plus g of x. The rest of it is the same. The only funny looking part here is this one where it says, g of x cannot equal 0. The only reason it says that is because you can't divide by 0. So, pretty straightforward there. Okay, we'll start off with a pretty simple one here. It says find what is the sum. Sum meaning you're adding the two. So you have your two functions f of x and g of x. What is f plus g of x? So f plus g of x, basically you're just going to add the like terms. So 5x plus negative 2x gives us 3x. Negative 7 plus 1 gives you negative 6. So 3x minus 6 would be the sum of those two. And then when you plug in negative 3, you can actually do this two ways. You can plug negative 3 into each function separately and then add them together, or you can plug it into the combined function. So we can just plug in negative 3 here. That gives us negative 9 minus 6, which is negative 15. And if we plug it in here, to the original functions, 5 times negative 3 is negative 15 minus 7. That one becomes negative 22. This one becomes positive 6 plus 1, so 7. And we add those together, we still get negative 15. So you can do it either way. Probably the second way is easier. So, alright, and then this next one, it says what is the difference, because you're subtracting. So this one's a little bit different because these are exponential functions, they're not linear. So if we do f minus g of x, we get 4 times 3 to the x minus 3 to the x plus 2. Okay, I'm going to erase this stuff up here so I can have some room. Okay, so if you distribute the negative, we get 4 times 3 to the x minus 3 to the x plus 2. Oh, just kidding, minus 2. Not bad. Okay, and these actually, both the 3 to the x's are like terms. The 2 is not because it doesn't have a variable with it. But think of this as 4 3 to the x's minus, this would be 1 3 to the x. Your 3 to the x is like your variable there, so you just subtract 4 and 1. So we get 3 times 3 to the x minus 2. And that actually, you can leave it like that, that's fine. But you can also simplify this a little bit because both of these are 3's here. So this is really 3 to the 1 times 3 to the x. And remember, if you're multiplying powers, you can just add the exponents. So this is actually the same as 3 to the x plus 1 minus 2. That would be f minus g of x. And then if you want to find when x is 2, you just plug it in. So f minus g of 2, we would plug in 3, 2 plus 1 minus 2. That would become 3 to the third, which is 27, minus 2 is 25. Okay, so that's just a little bit of algebra right here, skipping from this to this. And that only worked because they were both 3's. Like if this was a 5 here, 5 minus 1, that would be 4, and that wouldn't work. You would just have to leave it as 4 times 3 to the x. But because they both have the same base, you can actually combine them. So that's pretty neat. Okay, multiplying and dividing, same concept. Again, we have these exponential functions, so this will be a little bit more algebra, but that's okay. So we're doing f times g of x, which is going to be 2 times 5 to the x times 3 times 5 to the x. And when you're multiplying exponential functions, you can multiply the constants together, the 2 and 3. So we get 6 here. And when you multiply the 5x's, 5 to the x's together, it's all, you can think of it as 5 to the x times 5 to the x, or 5 to the x squared, because you're timesing it to itself. And then remember, when you have a power to a power, you can just distribute it here and multiply. So that becomes 6 times 5 to the 2x. And then this one wants you to plug in -1, so f times g of -1 equals 6 times 5, that'd be -2 up here. Remember, when you have a negative exponent, you need to make it a fraction to make it positive. So that would be 6 over, the 6 is still a positive exponent, so it stays on top. 5 squared on the bottom, which is the same as 6 over 25. So that is multiplication with exponential functions. And then we have this division problem, which division is actually probably the easiest to do, because actually I'm going to change it so it's not quite as easy. So let's change this g of x to 1/2 x minus 7 instead of 2x minus 7. That just makes it a little bit trickier, not really, but basically when you're dividing, you just make it a fraction. So f's going to go on top because the f's on top right here, so 4x plus 3 over 1/2 x minus 7. Again, x cannot, or the bottom can't be 0, but we'll worry about that in a second. This is not quite simplified because of the 1/2 down here. You don't want a fraction in the denominator, so you can multiply everything by the denominator of that fraction, so which is 2, but then you have to do the same thing at the top up here. So distribute the 2 through, we get 8x plus 6. These 2's will cancel, so we just get x minus, but you also have to go to here, 14. So now it's simplified. We just have to say this one does have a domain restriction because of the denominator. So you have to think about what's going to make the denominator 0. So, and we don't want that to happen, so we take our denominator, x minus 14, we set it not equal to 0, because we don't want it to be equal to 0. Solve for x cannot equal 14. Okay, so x can equal anything but 14. Just know that that is your domain restriction there. Okay, but this is your function. You would say, comma, x does not equal 14. So this would be your function there. And then when you plug in 12, f over g of 12, plug it in for x, so 8 times 12 plus 6 over 12 minus 14. 8 times 12 is 96. 96 plus 6 is 102 over negative 2. So that becomes negative 51. So f over g of 12 equals negative 51. And that's division. Okay, and then we just have this wildlife management problem number 3 here. So this is a biologist is studying the deer population in 2 state parks. She projects that the population in Park A in X years will be modeled by A of X equals 200 plus 25X. The population in Park B in X years will be modeled by B of X equals 100 times 1.05 to the X plus 40. What is a function giving the projection for the total population in both parks? So when it says total in both parks, we know that we need to combine the two by addition. Use the function to predict the total in 4 years. Okay, so this would just be A plus B of X. And again, we can combine our like terms here, which are actually just the 40 and the 200, because those are both constant. So we'll say 240, and we just add everything else on. Plus 25x from this guy, plus 100 times 1.05 to the x. Okay, we can't add the 100 with the 200 and the 40 because it is being multiplied to the 1.05. So that is actually one term. This right here is one term. This is one term. This is one term. And none of those are like terms. So we have 3 terms here actually. And that is all you can do, I think, because we don't have any of the same bases for anything. And we have a linear, so we have our constant, we have our linear piece, and we have our exponential piece. Those are all separate terms. Okay, and then the last thing is just to predict what it will be in 4 years. So meaning you plug in 4 for x. So 240 plus 25 times 4 is 100, plus, I don't know what that one is off the top of my head, so 1.05 to the 4th. And then we just calculate that, and it comes out to be what? So I got 461.55. And this is in, does it say what units this is in? I guess just single units, so about 462 deer in both parks. I was thinking it would say thousands or something like that, but guess not. Okay, and that is all for 14.4. And all of chapter 14 actually. So we have one more chapter after this, plus some honors topics that we haven't got to yet. So yeah, we should have plenty to do. All right, I will see you guys later when I see you, hopefully on Zoom at some point during this time, because there's still some of you I haven't seen since before I went to Mexico. So that'd be cool if you would, like, you know, jump on and say hi or whatever. But you do you.